functions works and derivatives works is going to say, oh, you have the profit function? Just look at the derivative of it and set it equal to 0. Because if I set this equation equal to 0, isn't that going to tell me the x that I need in order to find a flat tangent line? And the flat tangent line is going to occur at that peak. So this question of where this is happening, this max is where p prime of x equals 0. That's where it happens. It's the x value that I need to get a 0 slope out. The 0 slope, the derivative has to be equal to the 0 slope. So there's your derivative, right? Set it equal to 0. 45 minus 0.05x, set that equal to 0. And then solve this equation. So now you're back in like a basic algebra class. Solve this for x. So why don't we just get x by itself on one side? So how about if I take this and move it over? Can I do that? Since it's negative here, just move it to the other side. It makes it positive. 0.05x. And now divide both sides by 0.05. And what do you get? 900.
So at 900 units, you stop making money, and after that point, you start losing money.
That's right.
Yeah.
So what this represents, you've got the one person, your colleague, who's sitting in there going, we just need to sell more. Sell more, sell more, sell more. No, we don't need to sell more. We need to sell 900 units. This is where we will maximize our profit. If we sell less than this, we're not going to make as much money. If we sell more than this, we're going to make less money.
And that's all labor costs.
That's right, because let's say you actually need to pump out 2,000 car seats. You've got to hire people, you've got to pay for the electricity, maybe you've got to pay some overtime. It's all built into this, right? Whoever came up with this has already taken into account all of those things. And what's been determined is that 900 is the optimum number of car seats. You don't want more or less. Now, can you reach that? It depends on a lot of things, but that's what we're shooting for, right? Now, do you see that you can't really get that without the derivative? Like you can sit there and you can, like in the beginning of the problem, I said, hey, what's our profit at 800? What's our profit at 850? I could sit here all day long plugging in numbers and never be able to figure out where the maximum is. But with the derivative, if I just set it equal to 0, I've got it like that. See that? So, all right, that's kind of where we're headed. Here's what I'd like you to do for homework. We're not done, but I'm going to change the homework assignment for this section. It's going to still be the same problems out of the book, but my instructions are going to be different because the book does some stuff that I don't really care for. All right, so for this homework, for 10.4, this is on page 538. Here's what I want you to do. I want you to do 23 through 29 odds. And all I want you to do for this is find f prime of x. I do not want you to listen to their instructions. Their instructions are use the 4-step process to find f prime of x. Just do what we did in class for these 4 functions. You think you can handle that? Okay. Yes? That's all I want you to do. Find the derivatives for those functions. Then, hold on, not done. Then I want you to do number 79. 79 gives you a profit function. All right? And for this one, all I want you to do, oh no, sorry, they give you a revenue function. I want you to find r prime of x. That's all I want. Think you can handle that? All right. Now I have 10 minutes, right? So I think this is a good time to, what's that? To introduce you to the shortcut, to give you some sort of hope as to, you don't have to continue and do this limit over and over and over, all right? Because I guess I'm really hoping that I've somewhat sold you on the idea that the derivative can be useful. If you believe that the derivative can be useful, then you're going to want to take derivatives, but you're not going to want to have to use this limit over and over and over. So what we have is what we call our basic derivative formulas. Okay, first some notation. If y equals some function of x. We've seen that in college algebra. Haven't we done that before? We've said, oh, f of x is y, because it's like the y coordinate. Then y prime equals f prime of x. All this is saying is if I put a prime on the y, that means you're taking the derivative of the function. It's just notation. So anytime now, if I say, hey, find y prime, I'm telling you to find f prime of x. All right? All right, you ready for some formulas? I think you're going to like this. All right, so the formulas. And there's a few. I'm going to give you the first one. If y equals c, where c is a constant, then y prime equals something. All right, so I'm going to tell you what y prime is in a second. So y equals c is a function that is just a constant. Can someone give me an example of a function that's just a constant, like y equals 3? What does that look like if I ask you to graph it? It's a straight line, like what? Like that? Like what kind? It's kind of a special one.
It's the
Y equals 3. 3 is going to be vertical, horizontal, tilted, horizontal. Y equals a constant is a horizontal line like this. Always. All right? So if I asked you to pick a point on this line and asked you for the slope of the tangent line, what do you think it would be? It would be the same as the slope of the line, which would be 0. So if your function is a constant function, the derivative of that function will always be 0. So the derivative of a constant is 0. What did I say? The derivative of a constant is 0. Got it? Always. Second rule. If y equals x, then y prime equals what? So do we know what the function y equals x looks like? It's that function that's like a perfect diagonal. That's y equals x. Because the way this function works is if you plug in 1, it spits out 1. If you plug in 2, it spits out 2. If you plug in 3, it spits out 3. So it's like this perfect 45-degree angle. Does that make sense? What is the slope of this? What is the slope of this line? Like if I pick a point here, what's the slope? It's the same as the slope of the line, which is 1. So the derivative of x is 1, always. All right? The derivative of a constant is 0. The derivative of x is 1. And now the big one, the big formula. 3. If y equals x to any power, so x squared, x cubed, x to the 10th power, does not matter what it is, then the derivative of this is, now unfortunately, I can't prove this to you. This one, I tried to convince you by saying flat line, slope is 0. And on this one, I try and convince you by showing you like a diagonal, the slope is 1. On this one, you have to take it on faith, okay? I'm just going to give you the formula. And if this were like a real 2413 Calculus 1 class, we would prove the formula using a limit. In here, we're just going to hand it to you and say, take it, use it, and don't ask where it came from, okay? Now, if you want to see where it comes from, you come to my office, I'll show you. But it's exciting. All right, here we go. Here's what it is. N times x raised to the n minus 1. That's it. That's the formula. And this right here is known as the power rule. Now, in a regular Cal 1 class, we suffer through the limit for weeks. Like we do limits until the students are like bleeding limits. And then we show them the formulas and they get very angry. Like, why are you now giving me this rule after I suffered so much? And that's just part of calculus. You have to suffer through the limit. Here, we did a little suffering and now we get the formula, all right? So check out this rule. This rule is fantastic. What it says is that if you're trying to find the derivative of x to some power, all you have to do is take the power out in front and then just subtract 1 from the power. And that's it. You're done. Okay? That's it. So watch this. This because I'm almost out of time. And I'm going to get the sign-in sheet around. And we're starting it in the back, right? Didn't I say I was going to do that? Okay, so we'll start it back here. So check this out. What was the first problem that I asked us to do? The first one today. The first example we did. We had f of x
Equals
x
2x squared
2x squared plus 8, right?
Yes.
And I said find
X.
f prime of x, right? That's what I said to find? Which means I said find the derivative, right? So check this out. You see how you have a plus here? Whenever we're doing derivatives and we have a plus, we can always look at them individually. So let's start with the easier one. That 8. What's the derivative of 8? Well, 8's a constant, right? So the derivative of that 8 is 0, okay? Now we have something in front of it. Now you see this constant? You see there's a difference between this constant 2 and the constant 8. See how this 8 is by itself and there's no x's next to it? And this 2 is attached to the x squared? The question becomes, well, what do you do with that 2 if it's attached? You do not let it go to 0 like the 8 did. What you do is you ignore it. Just cover it up, just for a second. And now, what's the derivative of x squared? So that's x to the second power. So the 2 comes out front, right? So you'll have 2, what? I'm going to put it right here. You'll have 2 times x to what power? 1, right? Because you just subtract 1 from that power. That's what the derivative of x squared would be. Agreed? But what was in front of it that I had hidden? 2. That 2 is going to come for the ride. If the constant is attached to a function, it just comes for the ride. If the constant is by itself, the derivative is 0. That's a rule that I'll illustrate more later. I just want to get to this answer real quick, because what's that answer? 4x. And what was our answer? 4x. What was the second example we did? F of x is x squared plus 4x minus 7. Okay, so let's do these individually. What's the derivative of this? 2 comes out, x to the first power, right? Plus, now this 4 is attached to the x, right? So it's going to come for the ride. 4 is going to come for the ride. Cover it up. What's the derivative of x? 1, right? Now, minus, what's the derivative of a constant by itself? 0. What is this? 2x plus 4. That's the answer we got before, right? Yes? So these are not coincidences. These are the shortcuts. These are the formulas. These are the rules. We get to use them, all right? You like that better than the limit? Absolutely. Now, the drawback to this is that now that we have rules, we can actually try and do harder functions because we have shortcuts. All right? Yeah. So for the homework, just do what I put on the board, and that's it, okay? I would expect that we need to take a quiz soon. Yeah, we need a quiz, another quiz grade. Sign-in sheet's coming around.